We will write counting on 7 segment in this lecture too, but now we will use variables and arrays. First, let's see what are variables. When we write dim I as byte, a space is reserved in RAM. Its name is I and size is 1 byte. You can store from 0 to 255 any value. If I write I equals 5, 5 will be stored, and if I write I equals 20, 5 will be replaced by 20. If I write dim A as word, a 2 byte space will be reserved in RAM. Its name will be A. If I write dim X as double word, a 4 byte space will be reserved, named X. Now you can store any value between 0 to 255 in 1 byte. You can store any value 0 to 65,535 in 2 bytes, and any value between minus 2 billion to plus 2 billion in a double word variable. One point is very important, that choose variables very wisely, because the microcontrollers have very small memory, and most of the controller which we will encounter, they are 1 or 2 KB. So if you use large variables for smaller values, your space will end soon. So choose the variables very wisely, as hiring an aeroplane to go to office will not be a good decision. Another point, these names are not fixed names. You can write your own name. For example, you can write here that dim Ali as double word, or any other name you want. It is allowed. Now let's see what are arrays. Arrays are also variables, but it is a group of variables. If I write dim X as byte, a space, 5 spaces of 1 byte are reserved in RAM, like this. These are 5 spaces, 1 byte each, and their addresses are 0, 1, 2, 3 and 4. If I write x2 equals 20, it will go to address 2 and write 20 there. If I write x4 equals 1, it will go to address 4 and write 1 over there. If I write x10 equals 50, it will try to go to the address 10, but here you see there is no address 10, so the compiler will issue an error. So keep this point in mind too. Now let's develop the program. Save as 7 segment with array. Okay, delete these values. Define a variable dim I as byte, and this will a space reserved in RAM, and then an array of 10 variables. Dim A10 as byte. This will happen in the RAM. Now if I write A0 equals 3F, 3F will be written on address 0. If I write A1 equals 6, it will be written on address 1. Similarly, 5B will be written on address 2. Okay, now fill the whole array in the same way. After that, for loop for I equals 0, and when I write I equals 0, 0 will be written in I. Next, port D equals I AI. The value of I is 0 at the moment, so the value at A0 will be sent on port D. After that, the value of I will increase 1, 2, 3 and corresponding value will be sent on port D and counting will start. Let's compile. Compile successfully. Import new hex file. Let's run it. And yes, it is working fine. If you like the video, scroll down a bit, subscribe, ring the bell. You can comment, you can like, you can dislike, and if you think this video can help someone else, you can share it on your WhatsApp, Facebook, Twitter, etc. Thanks for watching.